MIT researchers working with scientists from Brigham have developed a new way to power and communicate with devices implanted deep within the human body. These devices could be used to deliver drugs, monitor conditions inside the body, or treat disease by stimulating the brain with electricity or light. The implants are powered by radio frequency waves, which can pass safely through human tissues. In test animals, the researchers showed that the waves can power devices located 10 centimeters deep in tissue from a distance of 1 meter. However, if the sensors are located very close to the skin surface, they can be powered from up to 38 meters away. Since there is currently a trade-off between how deep the implants can be and how far the radio waves can be out, they are now working on making the power delivery more efficient and transferring it over greater distances. This technology also has the potential to improve RFID applications in other areas such as inventory control, retail analytics, and smart environments, allowing for longer distance object tracking and communication. A research team from Harvard University wrote a paper published in the journal Cell that details an industrial process for large-scale capture of CO2 in the air in an affordable way. The process would suck in a lot of air, then pull that carbon dioxide out of that air and stick it into a liquid. Once in liquid form, they would separate the carbon dioxide again and then mix in some hydrogen to turn everything into a gasoline-like mix. This process is actually not the groundbreaking part, but they were able to make this affordable by designing a factory based entirely on parts that suppliers could already make cheaply by powering their prototype factory using natural gas, keeping careful track of their emissions, cost, and each stage of the design and production process. The research team notes that it would cost just $1 to $2.50 to remove from the atmosphere the carbon dioxide released by burning a gallon of gasoline in a car. Their team's plan is to make minor changes to their process for a better design, and they plan on making a process that involves an all-electric version instead of using natural gas to power their factory. Summit, which has been in the works for a few years now, is now the world's current fastest supercomputer with a peak performance of a whopping 200,000 trillion calculations per second. It has 4,608 servers with two 22-core IBM Power 9 chips, 6 NVIDIA Tesla V100 GPUs, and it has over 10 petabytes of RAM. The supercomputer is meant to be used for machine and deep learning applications, high-performance computing workload, analyzing massive data sets, and creating intelligent software to accelerate the pace of discovery. Although Summit is impressive, Summit can be seen as a placeholder, as supercomputers that are 5 times faster are in the works abroad and in the US. Still, Summit is something to behold, as it is currently the fastest supercomputer the Department of Energy has in its arsenal.